Hello my dear students. Now we are heading towards the next part of the lesson, that is tuned amplifier. Why not a general amplifier we have used here? Why it is we used here the tuned amplifier? Because they suffer from two major drawbacks in the general amplifier. They become less efficient at radio frequency. That means there are less frequency selective components in that kind of amplifier. Secondly, a general amplifier amplifies a wide band of frequencies equally. That means there is a less chance of changing the frequency, and also that is less selective in frequency selection, and does not permit the selection of a particular desired frequency while rejecting all other frequencies. That is the thing. We need a filter type of things or tuned thing to really amplify certain portion of the signal. So what is the tuned amplifiers? Amplifiers which amplify a specific frequency or a narrow band of frequencies are called tuned amplifiers. That means, first of all, amplifiers which amplify a specific frequency or narrow band of frequencies are called tuned amplifiers. That means that deals with the frequency. So tuned amplifiers are mostly used for the amplification of high or radio frequencies. It is because radio frequencies are generally single, and the tuned circuit permits their selection and efficient amplification. However, such amplifiers are not suitable for the amplification of audio frequencies, as they are mixture of frequencies from 20 Hz to 20 kHz and not single. In tuned frequency amplifiers or tuned amplifiers, here is the basic tuned amplifier. As you can see, that is quite similar that we have previously taught about in the oscillators. There is really a tank circuit, but if our output is not onto the amplifier side, is onto the side of the circuit, tank circuit, and the side of the that is the inductor, that will be a tuned amplifier. So that is the difference. As you can see here, that is a voltage divider bias circuit, BJT circuit. In the collector part, we have connected an LC circuit. In the parallel part of the LC circuit, we have created an output. That is the difference between oscillator and amplifiers. In oscillator, we will certainly take the output from here, but in a tuned amplifier, we take the output from the inductor. So if the input signal has the same frequency as the resonant frequency of LC circuit, large amplification will result due to high impedance of LC circuit at this frequency. When signals of many frequencies are present at the input of tuned amplifier, it will select and strongly amplify the signals of resonant frequency while rejecting all others. That means in a certain kind of input, there are a lot of frequencies. But if you set LC circuit, that means if you set a certain kind of frequency here, the amplifier will operate in that kind of frequency and reject all other frequencies in that matter. Here is the tuned amplifier operation. As you can see, consider a tuned amplifier that is designed to amplify only those frequencies that are within plus minus 20 kHz of the central frequency of 1000 kHz. So first of all, you have to calculate the total bandwidth. What will be the bandwidth? What will be the central frequency? The central frequency is 1000 kHz. Go 1000 plus 20, that's 1020 kHz, and just subtract to get the F1, that means the cutoff frequency of the lower part, that is the 980 kHz, and your bandwidth will be 40 kHz. That's the thing. There are another type of example of tuned amplifier. As you can see, there is the parallel RLC circuit that has been used, that has been given voltage source out, the outer part of it, that has been biased with the voltage. So the resonance frequency FR is 1 by twice by 1 by LC root over 1 by LC minus R square divided by L square, that is the parallel resonance frequency. And whenever you get R to 0, that means if R is equal to 0, if there is no R resistance is there, so we will get this. That is the pretty much quite similar to the oscillator type. So there are two type of things, that creates a small R and large R. Here one thing is pretty much predominant. What is the predominant thing? As far as the resonance frequency, whenever the R, the resistance is smaller, it increases to the peak point. That means at this point the R is smaller. If the R is equal to 0, you will get to the top of the peak point. That means the I maximum will go through to the circuit if there is no R. Okay, so the circuit will be like that. It's like this, and the selectivity will be high. Okay, and there is the bandwidth will be lesser, but there is wide bandwidth, but selectivity is quite low, and quality factor is also low if a large R is used. That means in large R, the less current will pass through to the circuit, and it will be less selective than the previous ones. Now, what are the advantages of tuned amplifiers? They have a small power loss. A tuned parallel circuit employs reactive components L and C. Consequently, the power loss in such a circuit is quite low. There is a high selectivity. A tuned circuit has the property of selectivity, that is, it can select the desired frequency for amplification out of a large number of frequencies simultaneously impressed upon it. Smaller collector supply voltage. Because of little resistance in the parallel tuned circuit, it requires a small collector supply voltage VCC. So there are three kind of advantages. First of all, small power. Second is high sensitivity. Third is smaller collector supply voltage. Here is a single tuned amplifier. Here you can see there is a single tuning, that is the AV, means the voltage gain across that is the voltage gain versus frequency curve. As you can see, maximum voltage gain will get when we operate in the resonance frequency. That is a single tuned amplifier. Very much simpler than the previous one. So double tuned amplifier, yes, the same thing is here, but here you can see there is a coupling type of thing that has been came through. In double tuned amplifier, you can see there are two inductors that has been put through face to face to couple this electric field, to couple this magnetic field between these two L1 and L2. That is the coupling that you can see here. There is the load side, there is the input side. So that is the double tuned amplifier. Here you can see if it is a tight coupling, you can get two frequency FRs. Okay, that is the tight coupling. You can get two FRs, but there is a single FR in the loose coupling sector. That is the thing. If it is coupled tight coupling, known as tight coupling, so that will be the high peak. The high peak of frequency resonance will be dropped down. There will be two peaks of resonant frequency, and in the loose coupling, it will generally gets higher and go to the uniformity of the resonance frequency. In double tuned amplifier, what are the advantages? Their bandwidth is increased. Their sensitivity, ability to receive weak signals is increased, because there we can see there are two in tight coupling there are two resonance frequency peaks, so they have more